Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Defects online support program, class 9, week 10, chapter number 2, subject chemistry, prepared by Maryam Qureshi.
Textbook Chemistry, page number 30 to 41, chapter number 2, Structure of an Atom. Topic included in this chapter are Rutherford's atomic model, Bohr's atomic theory, and electronic configuration. Objectives. By the end of the lesson, students will be able to know about Rutherford's atomic model, Bohr's atomic model, and electronic configuration. Topic isotopes is included from this chapter. So we will discuss only these three topics in our chapter.
So let's start with Rutherford atomic model. Rutherford atomic model was proposed by scientist Rutherford in 1911. Scientist Rutherford performed few experiments with different metal foils, and then after his observations he gave us some postulates about an atom. First of all, I will discuss Rutherford experiment, that what he did and what he observed in his experiments. Then postulates, and then at the end the defects of this model. Now Rutherford experiment. In Rutherford experiment, the scientist Rutherford bombarded thin gold foil with alpha particles. Thin gold foil mean thin gold sheets. Now what are alpha particles? Alpha particles are doubly positively charged helium nuclei. Actually, the alpha particles are the nuclei having mass number or atomic mass 4 and double positive charge. As you know that atomic number of helium is 2, and when these two electrons are removed from it, then it attains the double positive charge. So actually the alpha particles are doubly positively charged helium nuclei. After bombardment of alpha particles on gold foil, he observed that most of the alpha particles passed straight through the foil, few were slightly deflected, and about 1 billion deflected through an angle greater than 90 degrees. Now the question come in his mind that why it happened, why some rays are passing straight through the foil and some are deflected. He repeated the same experiment with foils of other elements, but he observed the same result. After his observations, he drew conclusions and gave us postulates. I will discuss the postulate, but first of all, look at this picture. Now, look at this picture. In above picture A, you can see a source of alpha particle, a beam of alpha particle, and a gold foil, which is placed inside a detector. Detector actually detect the position or location or deflection of alpha particle. In below picture B, an atoms of gold in gold foil has been shown. You can see that some rays are passing straight through the foil while some rays are deflecting. Now why it happened, I will discuss that in postulates. Now come toward postulates. The first postulate is, in the center of an atom dense positively charged region is present called as nucleus. Scientist Rutherford said that inside the atom a dense region is present that contains positively charged particles. So when positively charged alpha particles strike with these positively charged particles present in the center of an atom, they got deflected. And he named this positively charged dense region as nucleus. Second postulate is, most of the space occupied by an atom is empty, so that's why most of the alpha particles pass straight through the foil. Third postulate is, massive alpha particles are not deflected by electrons. As alpha particles have double positive charge and electrons have negative charge, so there will be attraction between positive and negative charge. Secondly, alpha particles are heavier than electrons, so that's why they are not deflected by electrons. Now, defects of this model. There are two major defects in Rutherford atomic model. The first defect is that, according to Rutherford, electrons being charged particles will emit energy continuously until it would fall into the nucleus. But actually it doesn't happen. Never ever the electrons fall onto the nucleus. Second defect is that if electrons are continuously emitting energy, it should form a continuous spectrum. But a line spectrum is obtained for an energy of an electron in an atom. Now look at this picture. In this picture you can see a graph for continuous spectrum and a graph for line spectrum. Spectrum is actually the combination of colors. The electrons emit energy in the form of photon. Now the scientists claim that if the electrons are continuously emitting energy, then a spectrum should be continuous spectrum for the energy of electron in an atom. But we obtain a line spectrum. So the scientist Rutherford failed to explain that why it happened and what is the logic behind line spectrum of electron. Now, students, it was all about Rutherford atomic model. In the next video, I will discuss Bohr atomic model. Thank you.